Hello, and welcome to the Data Engineering Podcast, the show about modern data management. When you're ready to build your next pipeline or want to test out the projects you hear about on the show, you'll need somewhere to deploy it, so check out our friends at Linode. With 200 gigabit private networking, scalable shared block storage, and a 40 gigabit public network, you've got everything you need to run a fast, reliable, and bulletproof data platform. And if you need global distribution, they've got that covered too, with worldwide data centers, including new ones in Toronto and Mumbai. And for your machine learning workloads, they just announced dedicated CPU instances to ensure that you get the performance that you need. Go to dataengineeringpodcast.com/linode, that's Linode, today to get a $20 credit and launch a new server in under a minute. And don't forget to thank them for their continued support of the show. And managing and auditing access to all of those servers and databases that you're running is a problem that grows in difficulty alongside the growth of your teams. If you're tired of wasting your time cobbling together scripts and workarounds to give your developers, data scientists, and managers the permissions that they need, then it's time to talk to our friends at StrongDM. They have built an easy-to-use platform that lets you leverage your company's single sign-on for your data. Go to dataengineeringpodcast.com/strongdm today to find out how you can simplify your systems. And Alluxio is an open-source, distributed data orchestration layer that makes it easier to scale your compute and your storage independently. By transparently pulling data from underlying silos, Alluxio unlocks the value of your data and allows for modern, computation-intensive workloads to become truly elastic and flexible for the cloud. With Alluxio, companies like Barclays, JD.com, Tencent, and 2 Sigma can manage data efficiently, accelerate business analytics, and ease the adoption of any cloud. Go to dataengineeringpodcast.com/Alluxio today to learn more and thank them for their support. And you listen to this show to learn and stay up to date with what's happening in databases, streaming platforms, big data, and everything else you need to know about modern data management. For even more opportunities to meet, listen, and learn from your peers, you don't want to miss out on this year's conference season. We have partnered with organizations such as O'Reilly Media, Dataversity, and the Open Data Science Conference. Go to dataengineeringpodcast.com/conferences to learn more and take advantage of our partner discounts when you register. And to help other people find the show, please leave a review on iTunes and tell your friends and coworkers. Your host is Tobias Macy, and today I'm interviewing Tim Ward about CluedIn, an integration platform for implementing your company's data fabric. So, Tim, could you start by introducing yourself?
Yeah, sure. And first of all, thanks for having me on, Tobias. My name is Tim Ward. I've been working in the software engineering space for around the last 12, 13 years, and mainly focusing in the kind of enterprise space. Myself, I'm based out of Copenhagen, Denmark, and I have a little boy and a little dog that looks like an Ewok, and my wife all live in small little Copenhagen.
And do you remember how you first got involved in the area of data management?
Yeah, so based off the fact I've been working in software engineering for that long, it was around 6 years ago that I got my first glimpse into a new world. I'd been kind of focusing mainly in the web space, so building big websites for kind of big brands, and I got given a project which was around how do we optimize the content on the website to the right audiences. And you could probably imagine this comes with a lot of data as well. And in this industry of testing content, you would usually have this process called a split A/B test. Give two variations of a website, and which one is the more popular. And we had come up with this kind of interesting idea of, well, should there really be one winner, or is there actually that both are relevant to different audiences? So this took me down this rabbit hole of data mining, clustering techniques with machine learning. And what got me into the more data management piece is that I realized, oh God, I have to blend data from different systems, and it doesn't really blend well because it's not clean. And so I need to normalize the data. And well, fast forward to today, and I've been in the industry for the last 6 years now.
And so before we get digging too deep into CluedIn in particular, can you start by sharing your definition of what a data fabric is? Because there are a lot of different resources that people might look to that might have conflicting definitions, and that way we can have a sort of consistent view for the purpose of this conversation.
Yeah, well, I mean, first of all, I will apologize for introducing yet another data acronym in the data space. I think we don't need them anymore. We've got data lake and data warehouse and data marts, and now we've got data fabric. So for that, I apologize. But if you if you look up Data Fabric on the web and you find us, you'll see that we're kind of talking about this idea of a foundation or a fabric across our content. And really it comes down to, when I first got into this industry, I realized how overwhelming the data space is. And I mean, I guess just some of the keywords or buzzwords I mentioned before, like data integration and data governance and data warehouse, it just was overwhelming from a technology stack. And when we started the platform, we saw this common theme of people were buying these kind of individual tools like a data warehouse and business intelligence tools. But really where most of these projects failed was the kind of stitching of all of these different pieces together. So suddenly, if we had bought a purpose-fit integration platform, and now we had purchased a best-in-breed data preparation tool, we had this huge challenge of how do we make that a coherent and cohesive story. And so when we describe the data fabric, you can think of it more as this kind of plumbing or this stitching where we know that at the end of the day, you might already have bought a data warehouse. It's probably been around for a very long time. But what you miss is this kind of core stitching and plumbing of an end-to-end story. So when we talk about fabric, it's really about how do I make sure that when I've got data coming in, that it's giving value to me at the end. And those end use cases will typically be things like visualizations in charts and BI tools. It could be, figuring out patterns in your data using machine learning techniques in tools like Data EQ or Azure ML or RapidMiner. So really we're wanting to kind of make this stitching solved, and you can plug in your parts where you see fit.
And so that brings us to the work that you've been doing with CluedIn to make this whole process of stitching together different data sources easier. So can you give an explanation about what it is that your mission is at CluedIn and some of the story of how it got started?
Yeah, sure. I mean, really, we're interested in helping companies become data-driven. And this means a lot of things to me as well. There's another data acronym for you. So for me, the idea of data-driven is that I, as a company, am using data to make very decisive decisions. So something that I could also not just use as a gut feeling or a hypothesis, but something that I can point at a screen and say, hey, here's the data that's actually allowing me to make my opinion or give this input. And we think it's so important to also be able to trace that data back to where did it come from? How was it cleaned over time? How stale is it? What's the quality? What's the accuracy? And I also saw all of these pieces as, missing in the market and something that I would like in the core fabric or the core plumbing. So, I mean, like any good story, I guess it starts with a necessity. We, a couple of the engineers at CluedIn were working at a larger enterprise, and we were at the time a small core engineering group. And you know a lot about what's happening in the business when you're that kind of small team. We knew who our customers were. We knew what was wrong with our platform. We knew what our customers were asking for. That kind of communication was there. And as most businesses do, they grow. And within a year, we had grown from 5 kind of core engineers to 125. And we lost this connection to why we were building this product. Why were we building what we were? And like any typical engineer would try to solve things, our CTO now at the time, he said, well, why don't I just build this kind of hub, and I can get everybody to kind of plug in all the tools that they use, like the CRM and the marketing tools, and I'll just go there to figure things out instead of, God forbid, talk to people or take meetings. So it has a very typical engineering start, but really what happened from there was this natural progression of, well, if I look up a particular customer, well, I get 10 different results, but they're all the same customer. So, okay, I have to introduce maybe some deduplication or a merging engine. And then we realize, well, things don't always merge perfectly, so we need a fuzzy merging engine. And, this would probably be represented well in a graph database instead of just one type of data format. And, then you come to this natural step of, well, I can't form a graph properly if the data's not clean and normalized. So this really snowballed into this kind of self-fulfilling prophecy where it's landed today as this kind of like core stitching of the data foundation of a business.
And as far as the types of customers that you work with, I guess if you can just describe what the ideal customer is, as far as whether they're a technically oriented organization or if your aim is to be just sort of plug and play where somebody just sends you data and then you automatically do the integration and send it to their destinations or integrate it with the various data streams that they're working with.
Yeah, so I mean, there's lots of good pieces there in this question. I mean, the piece automatic, right? You could probably imagine, there's no magic in our field, Tobias. There's rules, there's techniques, and there's things that fall through the cracks. So I mean, funnily enough, our ideal customer is large enterprises that have a huge problem, right? Thousands of tools. God forbid you have to integrate these 1,000 tools into one central hub and then clean it and then kind of invent all these processes themselves. And there is a lot of different things and techniques we can use in our field right now to automate some of the cleaning. So things like standardizing on a date format, things like normalizing phone numbers into ISO formats, trying to do a relatively good job at, normalizing addresses and things like this. And there's really no science to some of these things, but there are things that fall through the cracks. So really our goal with our ideal customer would be, hey, you've got a mess with the data. It's not blending well together. And therefore, when you see that data in your, BI tools or your machine learning tools where you're actually going to get value, you're not seeing that value. And really our goal is to put in the processes and the pipeline to say, hey, we're facilitating a process for you to improve this quality over time. So it's really large enterprise customers. And, funnily enough, the majority of our customers are in the finance and the insurance industry. And a lot of this also comes down to regulation. A lot of these industries are put under more strenuous regulations than, for example, maybe technology companies today. And, living in Europe, there's strong policies are now around data privacy and, what data they can have on individuals. And all of this plays a role in really kind of focusing on enterprise businesses.
Yeah, and your point that you were making about regulation and compliance requirements that these companies are dealing with, I'm wondering in particular how you manage that at the architectural and system level in terms of managing data privacy and security as it transits your system and what the sort of deployment environment looks like, whether you're running a hosted system that people send data through or if you're co-located with the data to reduce some of the latency effects of having to cross network boundaries, and just some of the overall ways that you have built your company and the ways that the data flows through.
Yeah, I mean, it's you could probably gather that a lot of our customers are really interested in not only hosting this environment in their own premises, in their own kind of virtual machine clusters, but a lot of them have kind of got, they're moving into the cloud, and some of them even have this kind of hybrid approach. So really the architectures that we're seeing is, first of all, we have to start with a good base, right? So if someone's going into the cloud, it's so important that we're adhering to the kind of leading security, network, and at-rest encryption. So things like TLS, things like SSL, things like making sure that we're running all of this behind VPN infrastructure. Now, it's so important, of course, with the customer data that as it's flowing through, and if we're encrypting it at both network and at rest, we also need to make sure that we held the highest of encryption, at least as the same or higher than any of the sources. So, for example, if we plugged in something like the Office 365 stack and we were analyzing something like mail or calendar events, well, we would need to make sure that we're running at 256 AES encryption at the data level, that we're using industry standard protocols for network transfer. So that's the security side of things. And then there's really the privacy side of things. So one of the ways that we help with this is within our platform, you can manage what's called the consent. What do you have consent for personally identifying data? And in fact, one of the ways that we help with this is because we're cataloging the data that comes through this pipe. We're looking at what are the fields coming from Salesforce? What are the fields coming from the ERP system? This allows you to have a direct mapping between hey, for this individual, we have the consent to use their email address and their phone number and their first name and last name in these specific situations. But governance is also so much bigger than just compliance. There's also the policies around what do we allow to flow through this stack. What if I see something like a credit card come through this pipe? How should I react to it? And kind of the ways that we support that is, there's two different types of ways to react to that. One of this is just to be notified and alerted that, hey, you've got this data and, it's high risk. The other is, hey, I need to, stop, right? Don't let this data go any further to upstream consumers like the data warehouse and, machine learning platforms. And, we often see that this is something that is not really covered in data governance. The typical data governance is, hey, can we set up some rules around ownership of data, ownership of products? And I think one of the things that we miss in our industry is, how are we actually tracing that against the actual data? And I think this is why, this is a problem for most companies, and to some think it's kind of unsolvable to be able to really meet all these regulations. So we're making sure that we cover off these kind of security blankets of, hey, if you've got data flowing through us, at least we've got you covered on these kind of main pieces and concepts that you'll need.
And as far as the overall life cycle of data as it traverses your system, can you just talk through the sort of different components of how you're processing it and the systems that you're running and some of the evolution that has gone on since you first began working on CluedIn?
Yeah, definitely. I mean, you'll probably agree that everything in our world starts with getting the data. And so, the integration layer, that's really where it starts. And I often like to say that platforms like CluedIn are useless if you can't put data through it. So, the way that we help there is, first of all, we've got, over 200 integrations to popular platforms like Salesforce and SQL Server and Oracle databases, Hadoop, the common kind of big data type of environments as well. And one of the things that we do first off, as the data is flowing through, the absolute first thing is we start to score the data raw. So we start to look at the data on about 12 different metrics. And these are your classic kind of, data quality metrics like accuracy and completeness. And, because we're using certain technology, like one of the databases I think I'll probably touch on a few times throughout this is the graph database. This allows us to also measure things like connectivity of these records. And the reason why we bring it in raw is one of the kind of common architectures we see is that a lot of people are introducing this idea of a data lake, i.e., a place to dump all the data from all the different systems. You get a ubiquitous language, typically via something like SQL, to be able to query this data in a common format. And that's what allows us to say, hey, that's great. If you've got that, instead of the data going directly from the sources to CluedIn, why don't we go through the data lake first, and that CluedIn will then integrate with the data lake itself. And so that's that pivotal step of allowing flexibility is also why we often refer to ourselves as this data fabric. But I think we would both agree, Tobias, that data by itself is really not that valuable. I mean, in some cases, especially with privacy, it's kind of sometimes more of a liability. And so, the ability to score this data on these different metrics, we're setting it up for a whole bunch of processing and tests that we're going to do on it. And so the next kind of natural step in the pipeline is, hey, well, I need to prepare this data to do some analysis. So one of the ways that we've tackled this is we actually use 5 different database families to store the same data. So you can imagine that a relational database is very good at doing certain things. It's what runs a data warehouse typically. It's very good at aggregating data. It's been around for a very long time, so it's solid and it's robust. But it's just not good at doing things like modeling data that is more in kind of a graph or network model, which is, to be honest, how most businesses actually are modeled. And so we're saving these same records and persisting them into these same database, these different database families. There's a lot of value we get out of this. First of all, we can ask questions of our data that we couldn't just ask to a relational database, or God forbid, shouldn't ask to a relational database. But the other great thing is when we're wanting to get data out of our system, okay, so I have some pretty interesting querying techniques. I can do queries that are part graph and part search index and part columnar store and kind of munge it all together into this Frankenstein type of query, but we can also optimize that query to run against the right databases. So once we've got it in these databases, of course, we're going to start applying these kind of classic cleaning techniques like normalization of dates and things like phone numbers and maybe even some simple things like genders, and of course things like normalizing types like, hey, this is an integer, this is a float, hey, let's normalize this so people don't need to do it upstream themselves. But things fall through the crack, right? There's no magic to this industry. There are just some things that need a manual application. So for that, that's when we kind of bring CluedIn clean into the whole pipeline. It's the ability for a data engineer to really solve the normalization and standardization things that really can't be automated very easily, or at least not very statistically confident. So once we've gone through these cleaning techniques, really the next thing is the governance piece is applied. Are you even allowed to send this data upstream? Do you have any personal data coming through or high risk data that we should be alerting the system of? And really the end point of CluedIn is kind of sometimes unfortunate for us, but we stop really where the fun happens. At that point, we just say, hey, here is the data. It's been blended. It's cleaner. It's more accurate. I've traced where it came from, so you can always audit it. Now go do something with it. And that's why we've brought GraphQL into the situation. Have you had a chance to play with GraphQL, Tobias?
I haven't done much work with it, but I have had a number of conversations about it. I know that the dgraph project uses a modified version of GraphQL as their query language. And on my other podcast, I had an interview with a gentleman who has been building tools for simplifying the creation of GraphQL APIs in Python and in JavaScript.
Got it.
It's definitely an interesting approach to the sort of overall problem of saying, I just need this data. I don't care how it gets to me, and then pushing the sort of responsibility further down the stack. So it makes it easier at some layers and more complicated at others. But I think that in just terms of just overall system design, it sort of simplifies things and just adds a fairly useful abstraction layer to it.
And that's the word. It's the abstraction. It's, in engineering, when you dial up simplicity, you lose more functionality sometimes. And I like to describe GraphQL more as like it's kind of like a schema for a query language. And, you can do what you want with it. And, if you want it just to talk to a relational database, go for it. But I mean, in our case, we're in this good position where we say, hey, I've actually got the same data in 5 different database families. So if I want a part of the GraphQL query to run against the search index, because that, maybe we're doing fuzzy searching, or maybe we're searching in different languages, and traditionally they're harder to actually achieve in the other types of database families. We can say, okay, why don't you do that part in the search index? And when you get to the part where you're getting out the results from GraphQL and you need edges, well, don't get the relational database or the search index to do that. Why don't you get the graph to do that piece? So that's why I kind of describe it sometimes as this Frankenstein of languages. But like you said, that's kind of, that complexity is abstracted away from you. And in the end, all you kind of get is the power of SQL, but kind of just the select part and the where part, because by that point, the data's already been joined. So this whole complexity around, well, I need data from Salesforce and I need it from Dynamics, but now I need to figure out the inner joins or the outer joins to actually blend that data. That's already been done before this. So that's why we also like to say that it makes this data much more accessible to the business, because we don't have to be domain experts in one system or many systems to actually get the data that we want out.
One of the things that I was curious about as you were discussing using these different storage engines and being able to leverage their different sort of strengths and capabilities is in terms of ensuring that you're able to reconcile the records as they get split out across these different systems and make sure that you are able to keep track of them individually and in aggregate. And in the event that there's something like a GDPR right to be forgotten request, you're able to then go back through and delete them from from all the different systems where they need to be removed from, and just some of the overall sort of record keeping that you use to be able to manage all of these different databases and ensure that there is some sort of consensus across them.
Yeah, exactly. And you could probably, I mean, just by you asking that question, I mean, you've probably already done, your research and thought, maybe this is something where it's kind of more eventual consistency based, because when you've got, the kind of the backbone of CluedIn is a message queuing system called RabbitMQ, and all of these databases are essentially saying, hey, I'm just going to consume the queue called create record. But even though the individual databases could be transactional, in no way do we wrap an entire transaction over 5 databases. That's just fraught with issues. You would, and of course we do have these mechanisms, but in theory it just won't even, I don't think, even work in reality. That what happens if we have a lot of retry mechanisms where we try to enter in first one, second, third, fourth failed, do we go back and clean up? There's nothing transactional about that. And so one of the ways that we've addressed this is actually that now there is what you would call like a write first journal, so like a log. So all of the messages that are consumed off the queue that's coming from these different sources, it's actually just written into one log file, like an append only, super fast write speed. And then what the databases do is they're basically reading off those logs. And the great thing about that is that instead of having this kind of, hey, insert this and then insert this next thing and insert this next thing, these systems can say, hey, go get me 1,000 lines off the log and process that all in one big call to the database. And then of course that piece is transactional. So in the end, what you get is CluedIn is a system that has eventual consistency across the stack. And to answer the question around the kind of GDPR subject request right for portability part of the question, first of all, let's start with it's hard. It's a really hard problem to solve. And sometimes people will talk about one of the things they want to do with their data is this single view of the customer. And I've never seen a system do this very well without having to do a lot of the work yourself. When you kind of think about it, the single view of the customer and also this right for portability, it's a kind of a similar problem. You want everything connected to an individual, but you really want to just highlight the things that are personally identifying. That's more for just the portability. You've got to have the right to remove that data if necessary. So you could probably start to see that a graph database seems to be a really good structure to host data connected to things. And in this case, it's a person. What we need to make sure we're doing is, as the data comes in, we are cataloging it so we know, hey, this job title of CEO, it came from the Salesforce contact record. And what this allows us to do is, with this lineage, if we're wanting to kind of change that record in our system, you can kind of think of it like a master data management type of component of, hey, Tobias has rung up our company. He's told us actually we've got some of his data wrong, like we've got the wrong job title and we've got the wrong phone number. We can actually change that in the CluedIn platform. And then it will basically say, hey, got it. So, and this is what we call our mesh API. It basically can unravel and say, hey, here are the queries that you need to run against the source systems to be able to change those values in the source systems. Now, there is a lot of complexity around that, right? So, what happens if we want to delete a record, and then when we look back at the database, we realize that it's got the need for cascading deletes. So it's going to throw us a kind of an exception saying, yeah, you can't just delete the contact because he's got referential or she's got referential integrity to these other tables. So there's all these complexities, and that's why a lot of the time these are, we give this kind of skeleton and framework for our customers to be able to implement it. But I guess, Tobias, also, this is this whole idea of unstructured data and even structured data that's not clean. We often say to our customers, really, if you're wanting this type of privacy solutions, just know that it's more about confidence that you have the right data rather than something that can just be 100% solved.
And particularly in the area of data cleaning and being able to reconcile records across these different systems, I'm wondering what you found to be some of the most challenging aspects of that integration step, and any specific requirements for domain knowledge or manual intervention across industries or across sort of business verticals and any steps that you incorporate as part of the onboarding process and ongoing execution of these integration routines to make sure that your customers are able to ensure that these integrations and reconciliations are happening appropriately?
Yeah, well, I think it starts with this idea of what we call our core vocabulary. You can think of it as like a schema as well. Basically, what we've done is we've said, okay, listen, a person is a person. Whether they exist in Salesforce or Dynamics or HubSpot, they're still a person. They have these generic properties that exist no matter where the source system. Now, they might call them different things. We might call them, last name and might be surname in another, but effectively they're the same thing. So this idea of this kind of core vocab is kind of what gives us this pillar of structure in what could be very unstructured. And I mean, the complexities with integration really start with the conceptual complexities, i.e., I know you and I, Tobias, could probably sit in a room with a whiteboard. We have 3 systems to connect. And we could probably draw up some boxes and say, oh, you have to join onto this table, but that'll give you the ID to join onto tool 3 and things like that. But if you look at the enterprise, as you can imagine, it's not 3 tools, it's 300, it's 3,000. In some of our customers' case, it's over 10,000 different systems. And this is a lot sometimes due to things like acquisitions, right? That you suddenly inherit this whole new technology stack and, what do you do about it? And so one of the complexities is there. And, one of the ways that we help address this is that, well, if I knew the end goal of this blended data was a relational database or a data warehouse, I'd have to be really careful about how I model this data. I wouldn't want to model it into a place where querying it would take too long or, just joining between too many tables is just, well, that's never going to scale at all. But the graph database is really good at flexible modeling. There are things it's not good at, but that's one of the things that it's really good at. So what this allows us to do at the integration level is say, hey, let's not only take a system at a time, let's take just an object at a time. And I'm not interested at all in how the product table and the customer table join. I'm not interested about that integrity. I'm more interested about what's a unique reference to this person or customer. Is it their email? Okay, let's flag that. Is it their phone number? Well, not unique, but it's a potential alias for it. And what that allows us to do is in what is typically an ETL world, where you might use something like SSIS or other ETL tools, we're much more of a ELT, where, hey, I'm actually going to load in all the data first, and I'm going to reverse engineer how these systems are joined. So you could probably understand that, when we plug in one system, we've got this customer in the graph, and he or she is just floating in the graph saying, hey, I don't connect to anything. It might be, 1 month later when we've plugged in system 15 that this other node says, hey, we've got the same ID, we should merge. So those kind of design principles have allowed us to kind of scale to these more larger installations. I think the final point around cleaning is that places like CluedIn, and as I described before as a data hub, they're the place to really standardize on how are we going to represent gender, right? How are we going to represent something like these categories or these labels? And I'm not so worried about changing them in the source systems because, they're probably like that in the source systems for a very good reason. But I do want to make sure that any upstream consumers off us are getting some consistency. They're getting standardizations. I don't want them to take care of this. Yeah, but in Salesforce, it's called gender, and in Dynamics, it's called sex, and in our custom-built system, it's in Danish or another language. I don't want them to think about that at all. I want to standardize on that at the clued-in kind of level. And so the classic cleaning challenges that we see, there's some really nice edge cases. Just something as simple as, hey, let's go get the gender field. Let's group the values or cluster them, and let's fix things like, oh, someone spelt male M-I-L, and or someone's done it in Danish, so it's man or kavina for a woman. Oh, let's clean those types of things. But sometimes we run into these situations where it's not so easy. So, for example, you might have a system that's trying to optimize for performance, and so it stores a gender as a 0 or a 1. And let's just say that 0 represents a woman and one represents a man. They might do that in one system, but in another system, the business might have flipped those. So it's not always easy as just saying, hey, just turn all the zeros into female and turn all the ones into men. There's these business cleaning rules that come in. So there's some of the complexities that we run into.
And as far as being able to manage the data lineage or data provenance, and then be able to expose it to the customer so that if there are any issues with the cleaning or reconciliation, or if there's just some incorrect data in the record, that they're then able to trace it back to the source system and maybe do some fixes for how the data is being transferred to you, or fixes in the source system itself, or how they're capturing the data originally. I'm just wondering what you're using to manage that and some of the challenges and benefits that you've found in the process of building that system.
Yeah, I think first it's probably a good idea to start with the object structure that we use. You can kind of think the object structure that we use is kind of like a Git object, right? So I would refer to it as like a versioned object graph, where you've got all the history, all the permutations, all in this kind of binary. And we've leveraged that idea, and we call this model our clue. And the interesting thing behind the clue model is that, hey, just because you have the data doesn't mean it's true, right? We need to be statistically confident, and making it statistically confident is something you get by throwing clues through our pipeline. And so what this allows us to do is then say, okay, well, I generically take in clues, and all of those clues have an origin. All of those origins also need a little bit more detail. They need what was the account it was added under as well. We want complete uniqueness of where the data came in. This allows us to kind of, I guess you could say, unravel this giant object, in some cases absolutely huge object. You can imagine maybe an Excel sheet, or the version history and of a very old Excel sheet. That's going to lead to potentially a large clue object. So we maintain all of that history. And why it's interesting is that, I guess the GDPR example is a good one. If I needed to ever purge the data, what I can actually do is I can say, hey, go get this record for Tobias, unravel all the history, and then remove the 13th clue that we got from Salesforce, and then reprocess that as if we never saw it in the past. So that's one way that we help with the lineage piece. But the other complexity with lineage is, well, where's the data going? And one of the ways that we help with that is, we have our GraphQL endpoint, and every time that you run a query, it will actually generate a new API token. So it's like, okay, well, we can use that to trace where that particular API token was used. The other way that we expose our data is still through GraphQL, but instead of this classic kind of paging of data, it will stream the data out of us. So it will use this kind of GraphQL streaming technique to say, hey, I've seen a new record, it's Tobias, and you have a GraphQL query that is looking for people called Tobias. Hey, I would match that. Where should I send you? And that stream can either be a classic stream, like maybe something like a Kafka stream or a Spark stream, or it could just be something as simple as like, hey, do a HTTP post over to this endpoint. There's some of the ways that we're able to trace that, hey, Tobias's data has come in from Salesforce and Dynamics. It's gone through the lineage and tracking in our system. And then we pushed it over to Power BI and to Azure ML. So you have that kind of end-to-end lineage.
And this problem of managing the destination and being able to push out to these systems that other people are using for analysis, but also at the other side of being able to consume the data and the number of integrations that you mentioned that you have. I'm wondering how you manage any changes in the APIs or the data formats, or any breakage or failures that might occur because of network outages or system failures or maintenance on the third parties, and just your overall strategy for ensuring that your system remains operable in the face of all these potential edge cases and failure modes.
Yeah, I mean, I will start by saying this. It's the hardest part of CluedIn is the maintenance of third-party integrations. I think one of the sanity points for us is that because our focus in customers is enterprise, that they are well aware that this happens, right? That if we're going to plug Dynamics 2017 into our system, I know in the world we live in that people are going to introduce new objects in Dynamics. They're going to introduce new properties, and how do we handle these? Well, in a lot of cases, I'll take the kind of Dynamics or Salesforce example, you could probably already realize you could do absolutely anything you want in those systems. You could branch out and not only use them for leads and contacts, but you could just put animals or hot dogs or any object you can think of. Now, a lot of these more enterprise tools, they expose it was a silly example, I'm aware, but a lot of these tools expose discovery endpoints where you can actually say, okay, well, instead of just guessing what your endpoints are, why don't you tell me what objects are available in your system? Now, this really only happens in the kind of more enterprise types of tools. Let's take something like HubSpot, which is more a CRM targeted towards small and medium businesses. It happens actually all the time that, and you could probably imagine this as well, is that they update their API and the documentation is not reflecting that. So one of the interesting ideas and processes we had in the past is that, well, why don't we just watch API pages, and when there's a content change, it'll alert our system and alert our team that, hey, okay, so something's changed on the page, and we would just use a standard diff tool to tell us what's changed. And this kind of is just flawed to start with. And it's because of this idea of usually the smaller companies are also innovating so fast, so they want to get these things out. And what happens in the end is that there are times when this just breaks. It just breaks. A good example would be HubSpot have stopped giving you back a list of people. It now gives you back a dictionary of people, and your serialization in your crawler didn't cater for that. So, I mean, the good thing is that you get signals from the system immediately that you have this issue. And in a lot of other cases, platforms are getting a little bit better and better and better at versioning, semantic versioning, and making sure that they release versioning in their APIs. So I guarantee that if you're using version 2, I'm never going to change that. But if you want to move to version 3 with the new stuff, yeah, I'm sorry, you're going to have to do some rework to deserialize that and move to the new models. So it does happen. It's a big piece of the work that we work on, but with proper alerting, we're pretty quick to act. It's in these cases where there's been such fundamental changes. It doesn't happen often. One of the, like I said before, one of the sanity checks for us is that our customers host this infrastructure themselves. And so typically they've got people dedicated to, hey, we've plugged in, Oracle databases and Workday and enterprise systems, and they're usually a little bit more mature around their release policy. So I guess what I'm saying is it happens. It's a very hard problem to solve. And I think the way to solve it is that businesses really need to fit more standards, right? We need to move towards much more standards of, hey, if you want to be a good business and expose your data, you need to adhere to at least these rules of the game. And actually, one of the ways that we're seeing this in an odd kind of space is actually in the authentication space. There's some proposals for standards out for the new OAuth. So OAuth 2, of course, is one of the kind of industry standards for authentication between systems. In the new version, they're talking about, hey, how can I just have applications talk directly to each other? How can I automatically spin up new applications without having to do them through some type of developer portal? So we are seeing these shifts towards more standardizations, but I believe it's the only way that we'll actually get sanity and any control over the complexities of integration.
And to your point about being able to alert on different failure cases or being able to keep track of the overall health of the system, I'm wondering what types of metrics you're using to keep an eye on that. And in the environments where you are actually deploying the system to customers' infrastructure, I'm wondering how you manage the overall life cycle and deployment model to them to ensure that they're able to stay up to date with the systems and that they don't have too much drift where they may decide 5 versions from now that they're actually going to upgrade versus actually staying with the current way that you're architecting the system.
Yeah, there's a couple of, I think there's a couple of technology choices that we bet on early that have just turned out really good for us in this space. So I guess the first thing is that coming from enterprise background, upgrading was one of always the big issues. How do you get your customers to upgrade? And in many cases, it will cost that customer quite a lot of money to put in the effort to upgrade your product. And so from day one, we bet on Docker. We bet on containerization. Then, these orchestration frameworks we took a bet on. And, what our deployment to our customers looks like now is, hey, here's some Docker containers. in a hub. Here is Kubernetes. Here's Helm charts. Feel free to use the services in the cloud to deploy those, or deploy this into your kind of VMware environment. And when I'm thinking about signals and metrics, I've actually moved in kind of into two kind of fields. I think for sometimes it was always around like DevOps types of metrics, but I actually think more our signals are more moving into the kind of data ops side of things. So for DevOps, of course, there's lots of metrics that, of course, third-party tools, and a lot of them are actually open source and fantastic, that just have native support for Kubernetes. So spin up, your Docker containers, spin up all your databases, put it into a Kubernetes cluster, orchestrate that with Helm charts as well. Oh, and let's bring in Grafana because that comes free. Let's put in NetStatD because that's got native support for that. So we would really, for the DevOps side, just say, hey, we're going to stay out of it, right? We're going to give you kind of industry standard ways for deployment, and then pick your tool of choice. Now, the signals with the data ops part becomes interesting because that's kind of a new field. And when I talk about data ops, it's more, if you want to be data driven, it's about how do you maintain a consistent flow of data throughout your business. And the thought of something as simple as a password change meant that data wasn't flowing from Salesforce for 24 hours or longer. I refer to that as data ops. So some of the signals and metrics we're sending from our system is, you've got an expiry on a token soon. Would you like to generate a new one and schedule for me to switch it in and out at a certain time? A lot of the other metrics, of course, I've already touched on would be things like data quality and data accuracy. And that's kind of more, I guess that's not as much on the data ops side, but they're still important things, because what I see in fields like us is what's becoming more important is how do I have people that are monitoring that I'm sending good quality data upstream? Because, everyone's relying on it. And to be honest, if I fix a few things, there's multiple people that win off it, right? We're all listening off the same pipe. And whether I'm a BI system or an ML system, they all want clean, good quality, enriched, complete data, and blended data is the other big thing as well. So I think the signals for us are really broken up into the data ops part and the DevOps.
And what have been some of the most notable customer success stories that you've experienced, or interesting or unexpected ways that people have used the CluedIn platform?
I mean, the one that always stands out for me is it's one of our cases around data privacy. And as a lot of businesses were doing, it was, getting to that time in May 2018, and a lot of companies were kind of scrambling. What do we do? We had a larger company that came to us, and they're just over 100,000 employees, and they said, "Hey, it's March. We have 124 applications. We're over 100,000 employees, so we have 25 years of historical data, and we want to hit May 25th. What can we do about that?" And once again, I think just down to some core technology choices like containerization of and clear separation of concern, and backing the system with a service bus. So hey, to scale this thing, you just introduce more machines, subscribe to the buses you want, and you're processing faster. Of course, the trick with that is every time you scale, you move the bottleneck somewhere else. So it was an interesting challenge in getting the system to basically say, hey, the bottleneck is the sources. We can't pull any faster because they're throttled, or there's quality of service that we need on the line because these are production systems. I think that's one of the great stories of just being able to integrate that amount of data within a few months, and to have them hit that date with the kind of high confidence that they could be compliant and fulfill the regulations. That was one. And I think some of the banks that we've been working with, just a lot of people are suffering from this kind of history of siloed data. And one of our customers have over 10,000 systems, and we don't integrate into all of them. In fact, it's a smaller subset. But I think for the part I like about it is that we gave them a view of this could do it. Like it's daunting to think how would you integrate 10,000 systems, and now with this kind of approach where you take one system at a time, and you take even one object at a time. I like the fact it's giving them this visibility of this. We could actually do this.
And what are some cases where a customer was interested in using CluedIn and it either wasn't the right fit, or they tried to get started with it and they weren't able to meet the sort of desired end goals that they set out with when they first started engaging with you?
Yeah, definitely. I mean, when you enter into the land of machine learning, you enter into the land of magic. So we've had some pretty fantastic examples of failures. I think one of my favorite is we brought on our first customer in the food industry, and as we're integrating their systems, there were a lot of PDF documents in file storage, and they were actually all the menus of all the different restaurants that they supported, kind of like they were an aggregator of restaurant data. And due to the kind of way that statistics work, and that's how a lot of these kind of natural language processing techniques are working as well, is just based off statistics. It detected all these menu items like spicy chicken as a person, and lamb korma as a person, and our system would kind of pop up and say things like, "Hey, here's the phone number of spicy chicken. Would you like to give them a call?" And it's really hard. It's really hard in those situations to describe. This is done off not off rules. It's not done off business logic. It's done off statistics, and we all had a laugh about it. But it also, for me, it showed me the reality of machine learning and where it's useful and where it's not. So I think that's one of my favorite failure stories. I have to tell one more because I always do this, and I always do this to embarrass our CTO. But I think you'll get a laugh out of it. Our CTO, Martin, he kind of looks like your classic Nord. He's got very long hair and has death metal shirts and like a beard. He kind of looks like Jesus a little bit, like the pictures and the drawings of Jesus. So we were using image object recognition to basically scan through images and say, hey, there's some objects in this image. And I placed to test out the system. I placed a picture of myself, and it was me at my brother's wedding, and it picked up glasses and a suit and bow tie, and we thought, wow, this is amazing. Like, how does this work? And we put Martin's picture through the same engine about 30 seconds later, and it, with 90% confidence, had classified him as a fur coat. And you really have to just look up a picture of his name is Martin Huldal, and you really just need to look up a picture of him to get the true emphasis of the laugh. But they're the kind of failures we run into.
Yeah, I think I might have actually seen the example photo when I was looking through your blog to prepare for the show, and get a good laugh out of it at the time as well.
It's one of those things that never fails to make me laugh as well.
And so, are there any other cases where you found that CluedIn is not the right choice and a company or organization is better off using a different system, whether it's because of the size of the organization and complexity that they're dealing with, or because of just the overall sort of goals that they have for managing their data integrations, or any sorts of issues with control or visibility into the system?
Yeah, I think one of the big things is that a lot of people are throwing this word around of like real-time data, right? So we've got IoT data and signal data. I would say to a person that we play no role in that world, right? Because it's kind of like this classic saying we have in engineering, like you've got all these dials, right? Speed, cost, right? If you move one, the others move accordingly as well. And for me, IoT data is about, hey, I need to get it, stream it in as fast as I can from the plane or the jet or the wind turbine, and I need to put it into like a logging system that's showing me real-time sensor data. And if you've got cleaning and accuracy and quality of data, don't fall into it as much, because, well, if the data's incorrect, maybe that's just a wrong reader that you've bought, right? Now, easier said than done because people buy different readers and they all, send data in different types of formats. But I would say that's one case where it's like, let's just stay out of that. As soon as you don't want anything tracked, you don't want it cleaned, you don't want it blended, there's no need for you to put your data through our pipeline. But I think overall, it's still nice to be able to set up an overall foundation for a company where you say, okay, IoT data, signal data, maybe it streams into something like, I don't know, like a Kafka stream, or maybe you're using like IoT Hub or Event Hub in Azure, and you just want to push it directly to the logging application. CluedIn just really doesn't play a role in that story.
And what are your plans for the future of CluedIn, both from the technical and business perspective?
I think from the technology side, it's really about just continuing with the robustness. So I think from kind of a feature set and functionality perspective, we're really happy with where we are, and really more it's about also making sure that we can adapt to new things that will come in our industry. I mean, it's going so fast. I didn't know what a data lake was a few years ago, and now it's the kind of thing that everybody wants. And in 2 years there'll be new things, and it's really about how we make sure that we're building robustness and flexibility to be able to adapt to those new requirements. So from a technical side, it's also making sure that we're always keeping up with industry standards, that we're always moving to frameworks that are better. For example, we're mostly built in .NET, but we've moved to .NET Core to get the wins from that. And from a business side, it's just more moving into other countries where they have these same issues. And we recently have moved into customers in Australia and the UK and the US, and you could probably imagine these problems exist everywhere with businesses. So I think that's the plan from the business side.
And are there any other aspects of CluedIn or data integration or data engineering that we didn't discuss yet that you'd like to cover before we close out the show?
I think I used more data acronyms than anyone could take any more of. So I think we've had a good discussion.
All right. Well, for anybody who wants to get in touch with you or follow along with the work that you and your company are doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest gap in the tooling or technology that's available for data management today.
Yeah, good question. I mean, I think I'm naturally biased when I say this, but I think it's this stitching, right? It's this, yeah, I can go out and I have a plethora of choices of technology, but how are these things going to work together? I mean, we can't only forget that integration's not just about from data sources into a pipe. It's from the pipe into the governance, and governance into the lineage, and all those different components. So, I'd like to see us, in a way, kind of like standardize on what is the plumbing that businesses need. And I think that's the biggest piece that is missing from the overall story, and why companies are finding it so complex to get value out of their data.
All right. Well, thank you very much for taking the time today to join me and discuss the work that you're doing at CluedIn. It's definitely a very interesting platform and a challenging problem domain, so it's always great to get a view of how different people are solving it. So I appreciate that, and I hope you enjoy the rest of your day.
Thanks, Tobias. Pleasure.